Fifth grade lesson 1.4 is power of 10 and exponents. The essential question is, how can you use an exponent to show powers of 10? You're familiar with powers of 10. What's new to you is exponents, and exponents will show you how you can show those powers of 10. Expressions with repeated factors such as 10 times 10 times 10 can be written by using a base with an exponent. The base is the number that is used as the repeated factor, the number that's being multiplied by itself over and over and over again. So we have 10 being multiplied by itself over and over again. We know, like, the repeated addition shortcut was multiplication. The repeated multiplication shortcut is exponents. So the base, of course, is the number that's being repeated. So 10, in this case, would be the base. The big number of the exponents is the base, big base. The base is the number that is used as the repeated factor. The exponent is the number that tells how many times we're using the base as the factor. So if I have 10 times 10 times 10, the 10 is repeating 3 times. So I put a little bitty 3 up here right in the corner, and this is his exponent. So the base is 10, the exponent is 3. This signifies that 10 is the number that's being repeatedly multiplied by itself, and 3 is how many times that is happening. So here we have 10 times, oh, they use the same one. Okay, 10 times 10 times 10, that is 10 to the third power. And 10 times 10 is 100, and 100 times 10 is 1,000. And notice when you're doing tens, it's nice because it's easy to put together 3 zeros. So the way you say it is the third power of 10, or you'll hear it said 10 to the power of 3, or 10 to the third power. And in exponent form, it looks like that. So let's use base 10 blocks to show 10 times 1,000 written as an exponent. So the weirdest part is this 10 to the 0 power. I have no tens here. I'm always at my starting point 1. Anything when you have it to the 0 power just stays at its starting point 1. The base hasn't started doing anything yet. So it's at starting point 1. So 10 to the 0 power is just 1. And this gets confusing a lot because people see to the 0 power and we think what we know about multiplying with 0, that it's 0. But it's not. Anything to the power of 0, like even if I have 5 to the power of 0, it's still 1. It's at the starting point 1. We haven't begun going times that number yet. So heads up on that. You'll get more into that later. Now we have 10 ones. That's 1 times 10. That's one set of tens. So that is 10 to the power of 1. I think I skipped this part. How many ones are in 1? There's just one in 1. How many ones are in 10? There's 10 ones in 10. How many tens are in 100? There's 100. There's 100 flat, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens in 100. That's 1 times 10, or 10 to the second power. 10 times 10 is 100. And now they're asking us how many hundreds are in 1,000. So this is a hundreds flat. How many of these flats make the 1,000? It would be 10. There's 10 hundreds in 1,000. And we can see 10 times 10 times, we have 1, the starting point, times 10 times 10 times 10. That's 10 being repeated 3 times, or 10 to the third power. So how many thousands would be in 10,000? There would be 10 of them, you guessed it. And in the box at the right, draw a quick picture to show 10,000. I don't even know if I could. All right, give me a moment. Okay, I did it. Sorry about the sloppy. This is one of these, and I did 10 of them stacked on top of each other. This is 10 times 10 times 10 times 10. There's 4 tens there, so it is 10 to the 4th power. So 10 times 1,000 is 10 to the 4th power. And when you're using 10 as your base, you can count up the amount of zeros, and that tells you what the exponent is. There's 3 zeros, it's 10 to the 3rd. There's 2 zeros, 10 to the 2nd. 1 0, 10 to the 1. No zeros, 10 to the 0. Let's look at another example. Multiply a whole number by a power of 10. Hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster its wings beat. The average hummingbird beats its wings about 3 times 10 to the third times a minute. How many times a minute is that written as a whole number? So if we multiply 3 times the powers of 10, let's look for a pattern. If I do 3 times 10 to the 0, remember 10 to the 0 is 1. 3 times 1 is 3. If I do 3 times 10 to the 1 power, that is 110 being multiplied times the 3. 3 times 10 is 30. If I do 3 times 10 to the 2 power, or 10 to the second power, I'm doing 3 times 10 times 10. 3 times 10 times 10. 2 10s being multiplied. The base gets multiplied. Okay, so 3 times 10 times 10, that is 100, and 100 times 3 is 300. And finally, 3 times 10 to the third, you're noticing this pattern here, right, is 3 times 10 times 10 times 10, because there's to the third power. So 3 times 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 3 is 3,000. So the average hummingbird beats its wings about 3,000 times a minute. What pattern do we see? This was 3, then 30, then 300, then 3,000. 3 times 10 to the fourth is going to be 30,000. Another 0 on the end. We just keep increasing the zeros on the end. So it increases by a multiple of 10. And that's pretty much the lesson. Now we're just doing the practice of it. They want us to write in exponent form and in word form. So exponent form, my base, what's being multiplied by itself is the 10. So that's my base, the big base. And how many times is that number being multiplied by itself? 2 times. 10 to the second. I think in word form they mean how I say it. Second. That's a C. Oh, gosh, that's terrible, Miss Sanchez. Come on. Power. I mean, people say it different ways. 10 to the power of 2, the second power of 10. So you get the idea. Now I have 10 times 10 times 10 times 10. The base, the number that's being multiplied is 10. It's being repeatedly multiplied. How many times is that base repeatedly multiplied? 1, 2, 3, 4 times. How do I say that in word form? For me, I say 10 to the power of 4. Or 4 powers of 10, somebody might say. Now they want us to find the value. So if it helps, break this back out down to from here to here so that you can see it. It's going to take some training of your brain to calculate exponents as you go along. And for a while, you may just want to break it back into its original form. That is 10 times 10, and 10 times 10 is 100. But also remember what I mentioned before. If you're dealing with a base of 10, then the exponent is telling you a 1 with how many zeros at the end. This one is a 1 with 2 zeros at the end. I have, this one is 4 times 10 to the second. That is 4 times 10 times 10. There's 2 10s being multiplied. 10 times 10 is 100, and 100 times 4 is 400. Here is, you can try this one. You can pause and try this one if you want. This is 7 times 10 to the third. That is 7 times 10 times 10 times 10. It's 10 multiplied 3 times over. 10 times 10 is 100, and 100 times 10 is 1,000. And 7 times 1,000 is 7,000. Or you could have said, oh, this 10 to the third power, since that's a base 10, that's 3 zeros on the end, 1 with 3 zeros on the end, and then multiply it by 7 if you're catching that. That's it for this lesson, really. It's just understanding exponents with a base of 10. You'll learn about exponents with different bases later, but for right now, just as we get comfortable with it, we're using the base of 10.